This presentation introduces VMware's software-defined enterprise-class storage solution, vSAN. vSAN powers industry-leading hyperconverged infrastructure solutions with a vSphere-native high-performance architecture. Virtualization has helped usher in a new level of agility in the data center, but has done so using storage systems that are not capable of meeting the evolving requirements of the IT industry. Addressing storage requirements in the data center has always been a challenge. It was made worse by technical nuances and architectures that resulted in very little flexibility in accommodating the changing needs of workloads, or increased demands of storage performance, capacity, or protection in an environment. This has resulted in many organizations experiencing buy yet another box fatigue. More importantly, traditional storage is unable to accommodate for the changing world of the data center and the need for it to be fully software-defined. A hyperconverged architecture can remove dependencies from hardware feature sets. By abstracting these features away from the underlying hardware, you can address and apply the right settings in the right way for each workload running in a data center. As organizations are looking for interoperability with other public or private cloud environments, being able to apply these settings in a granular way using software is quickly turning into a requirement. The storage architecture of the future is clear. It will be server SAN-based architecture, whether it's hyperscale cloud-based storage or hyperconverged infrastructure HCI. Organizations are shifting to HCI to address their IT and storage challenges, fueling rapid growth projections over 30% over the next several years, according to IDC. As a leader in the software-defined data center, VMware is ideally situated to simplify this transition to hyperconverged infrastructure. Our approach with vSAN also allows customers to seamlessly evolve their vSphere into HCI without starting over with new hardware, new hypervisor, or new management tool. Let's take a look at how VMware's HCI solution, vSAN, addresses these challenges with traditional infrastructure. vSAN is VMware's software-defined storage solution built from the ground up for vSphere virtual machines. It abstracts and aggregates locally attached disks in a vSphere cluster to create a storage solution that can be provisioned and managed from vCenter and the vSphere web client. vSAN is hyperconverged. That is, storage and compute for VMs are delivered from the same x86 server platform running the hypervisor. It integrates with the entire VMware stack, including features like vMotion, HA, and DRS. VM storage provisioning and day-to-day management of storage SLAs can all be controlled through VM-level policies that can be set and modified on the fly. vSAN delivers enterprise-class features, scale, and performance, making it the ideal storage platform for virtual machines. How a hyperconverged solution is implemented matters. Some solutions provide an HCI solution using a virtual appliance pinned to each host in the cluster to provide storage services. But this comes at a significant cost to the user, as the number of effective VMs per host will significantly be reduced, and the performance of the VMs will be more inconsistent. VMware vSAN takes advantage of being integrated directly into the kernel to offer supreme levels of efficiency, performance, and integration. This translates into a significant increase in the number of VMs per host as compared to the virtual appliance-based HCI solutions, with better, more consistent performance. Since vSAN is integrated into the hypervisor, it's aware of all the hypervisor activities and understanding of the cluster topologies. This drives down the operational complexity and is easy to adopt into an organization because it's software the user already knows. A wide variety of deployment and configuration options makes vSAN a flexible and highly scalable HCI storage solution. A single vSAN cluster consists of any number of physical server hosts from 2 to 64. Organizations can start with what is needed today and add additional compute and storage capacity as needed. Each host contains either all flash devices, referred to as an all-flash cluster, or a combination of magnetic disks and flash devices, or hybrid cluster, that contribute cache and capacity to the vSAN distributed data store. In an all-flash cluster, the cache tier is used entirely as a write buffer. The cache tier in a hybrid cluster is divided into 70% for read cache and 30% for write buffer. Each disk group contains one cache device and 1 to 7 capacity devices. All-flash vSAN clusters can achieve additional space savings using deduplication and compression. HCI powered by vSAN makes it very easy to incrementally add compute resources and storage capacity to a cluster. Drives can be added to existing hosts, assuming there are empty drive slots available. It is also possible to replace older drives with larger ones to increase capacity. In some cases, this can also boost performance by adding more cache and faster storage technologies. Adding drives to an existing vSAN cluster is commonly called scaling up. Another option is scaling out by adding new hosts to a cluster. This can be done without disruption and adds both compute resources and storage capacity to a vSAN cluster. Having the option to scale up and scale out gives administrators flexibility to easily add the right amount of resources as they're needed. VSAN 6.7 introduces a number of key features that help us provide an HCI solution for customers that want to evolve without risk, lower their TCO, and accommodate the demands of IT environments for today, tomorrow, and beyond. To help customers evolve their data center with HCI, the improvements of VSAN 6.7 focused on enabling customers to improve their experience in three key areas: intuitive operations experience, consistent application experience, and enhanced support experience. Today's digital businesses depend on predictable, available, and secure applications. From cloud-native applications to traditional business-critical applications, whether during upgrades or while recovering from a hardware failure, organizations expect applications to not just always be on, but to deliver consistent performance. VSAN 6.7 introduces a number of new capabilities that reduce deployment downtime and latency. vSAN deployments now reduce performance impacts during resync operations by monitoring application performance and dynamically adapting bandwidth allocations to minimize latency. vSAN also reduces the time resources are taken offline during common day 2 operations, such as entering a host into maintenance mode. VSAN 6.7 hardens stretch cluster deployments, ensuring application availability in the event of a site failure by enhancing logic in the event of failovers and resynchronization. It also provides new network efficiencies and accelerates resync performance, intelligently reducing the amount of data sent over the network by sending a single copy between sites and then replicating locally. In vSAN 6.6, VMware introduced the industry's first native HCI encryption for data at rest that removed the need for costly self-encrypting drives and encrypted data at both the cache and persistent layer. We're pleased to announce that vSAN's cryptographic module that delivers encryption for data at rest has FIPS 142- validation. This formal validation gives assurance to VMware customers that their vSphere and vSAN infrastructure is backed by a vetted, cryptographic system and enables compliance with federal regulations and industry standards such as HIPAA. For detailed information on all the new features in vSAN 6.7, be sure to visit storagehub.vmware.com. VMware vSAN is all about simplicity and efficiency. Let's take a look. VMware vSAN is an object-based storage system integrated into vSphere. Virtual machines that live on vSAN storage are comprised of a number of storage objects: VMDKs, VM home namespace, VM swap areas, snapshot delta disks, and snapshot memory maps are all examples of storage objects in vSAN. vSAN uses the concept of RAID tree to ensure protection of objects. A component is the leaf of an object's RAID tree and is how redundancy is provided to a given object. Components may be split into smaller components depending on the environment conditions and the size of the objects. Deduplication and compression is a great example of a software feature that may prevent the user from needing to buy additional hardware to satisfy capacity requirements. vSAN's implementation of deduplication and compression was intended to be extremely simple. The toggling of the features are enabled or disabled together as an overall space efficiency feature. Deduplication and compression, available for all flash configurations using the Enterprise Edition of vSAN, can quickly change the economics of flash to a level that makes the effective price per gigabyte of storage as affordable or more affordable than a hybrid configuration. Addressing changes in requirements can be a challenge and a potential risk for data center administrators. Requirements around security can often make compliance a much more challenging endeavor. By addressing concerns such as security of data natively in the hypervisor, one can have the confidence that VMware vSphere running vSAN can address those concerns efficiently and effectively using software that they already know. This is exactly what vSAN offers: data at rest encryption built into vSAN, easily enabled by a few clicks. vSAN 6.7 now expands the flexibility of the vSAN iSCSI service to support Windows Server Failover Clusters, or WSFC. vSAN already natively supports modern Windows application layer clustering technologies like Microsoft SQL Always-On Availability Groups and Microsoft Exchange Database Availability Group DAGs. For scenarios in which an organization has WSFC servers in a physical or virtual configuration, vSAN can support this legacy shared target storage location when the storage target is exposed using the vSAN iSCSI service. This allows data center administrators to run workloads using legacy clustering technologies on vSAN as they eventually transition to more modern implementations of application layer clustering like AAG and DAGs. Doesn't it make sense to control storage resources on a per VM basis in the hypervisor, just as you do your CPU or memory? Traditional storage solutions simply don't offer this level of control and are limited to providing one-size-fits-all approaches to storage performance and protection. This is where VMware's Storage Policy-Based Management, SPBM, comes into play. Levels of protection and performance are no longer reliant upon the capabilities of an external storage system, but are now controlled and managed by the hypervisor. Policies can be assigned to virtual machines and individual objects like a virtual disk. Storage policies are easily changed or reassigned as application requirements change. These modifications are performed with no downtime and without the need to migrate virtual machines from one data store to another. SPBM makes it possible to assign and modify service levels with precision on a per virtual machine basis. VMware's approach to HCI allows customers to protect existing storage investments while slowly evolving their IT to a software-defined data center. VMware's storage policy-based management extends per VM policies and automated provisioning to a modern SAN and NAS storage system as well as with virtual volumes, vVols. As a result, customers can connect their existing storage infrastructure to a vSphere cluster running vSAN, just like they do with vSphere today. Using proven built-in technologies like Storage vMotion, customers can easily migrate data between the various storage solutions within the cluster, enabling simple, non-disruptive migration plans. Storage policy-based management is extremely easy to implement. Creating a storage policy is nothing more than defining what your requirements are for a VM or a collection of VMs. These requirements are typically around protection and performance of the VM. A new policy can be created in vCenter and accessible for use by any VM served by the same vCenter server. Once a policy is created, the policy can quickly be applied to a VM. The VM will adopt the new performance and protection settings without any downtime. One can change the characteristics of an existing policy, and the VMs will adopt the most recent settings of that policy. The graphical UI is the most common way that vSAN administrators manage an environment. vSAN 6.7 introduces a new HTML5 UI based on the Clarity framework seen in other VMware solutions. Yet this solution is not just a direct port from the old UI over to HTML5. VMware took a long look at how tasks and workflows can be optimized and introduced new ways to accomplish tasks, but in a more intuitive way with fewer clicks. The HTML5 interface is a great step forward in providing vSAN users an intuitive, efficient user experience. This new way of presenting storage can dramatically improve how environments are deployed, operationalized, and optimized. Let's see how. VMware has taken a holistic approach when looking at the deployment, operation, and optimization of a vSAN environment. To that end, everything from day zero deployment activities, as well as day one and day two operations, have been integrated with vSAN to drive up operational efficiency and drive down total cost of ownership. VMware saw tremendous opportunity to improve the experience of running vSAN in the deployment of brand new clusters from scratch. Easy Install, starting in vSAN 6.6, provides a simple way to deploy vSphere and vSAN with a VCSA on a single host to then begin the process of adding additional hosts to the cluster. The result is an easy-to-use wizard incorporated into the VCSA installer that provides rapid deployment of a greenfield vSAN installation. vSAN Health is cloud-connected, and new checks are delivered through the vSphere web client. This enhancement consistently provides administrators with the latest checks, remedies, and VMware recommendations for optimal reliability and performance. New health checks appear as KB articles are created and published without the need to upgrade vSphere and vSAN. Proactive tests help validate the basic activities such as creating a VM can be performed and will allow for simplified storage performance metrics to be run. The new performance diagnostics analyzes the performance of a vSAN cluster against previously executed benchmarks. This is especially helpful for new deployments and POCs, An administrator can select a desired benchmark goal, such as maximum throughput or minimum latency, and a time range for which the benchmark runs. The results will be uploaded for analysis, returning a set of recommendations and KB articles courtesy of the Ask VMware button. This feature does require participation in the VMware Customer Experience Improvement Program, CEIP. There is API-level integration when using HCI Bench. This helps the administrator by sending the defined time period that a benchmark was executed back to vCenter and defines the time range for further analysis. vSAN now takes advantage of VMware Update Manager (VUM). This provides a seamless, automated process ensuring an environment is up to date with the latest version of vSAN. VUM with vSAN integration reduces uncertainty in applying updates and patches by creating HCL-aware baseline recommendations for clusters running dissimilar components. These baselines will package an upgrade bundle accordingly and automatically download all packages and ISOs. Most importantly, vSAN will only be updated to the highest level of compatibility, making the upgrade process a more predictable experience. vSAN Support Insight enables an improved customer support experience by proactively providing VMware Global Support Services (GSS) with data about a customer's vSAN and vSphere environment. This data is anonymized and then uploaded to the VMware Analytics Cloud, where it's processed and converted to useful information such as configuration specifics, performance, and health status. GSS can get to the troubleshooting effort faster when less time is spent on gathering this data. What does this mean to a vSAN customer? Faster time to resolution and a direct way to help VMware improve the product experience. vSAN aims to provide as much intelligence as possible about the state of the vSAN storage environment, all within the vCenter UI. With vSAN, you get a clear understanding of key data related to capacity available, capacity used, and a distribution of what is consuming the space. vSAN also presents a number of in-depth storage performance metrics and takes advantage of the integration into the hypervisor by not only showing back-end storage-related performance metrics, but interweaving this with VM-related performance metrics that are powered by vSAN. vSAN performance metrics detail many of the key metrics that are important to understanding system performance, while providing them all in vCenter and without the need for additional tools. VMware has always believed strongly in the API-first approach, and with vSAN 6.6, the SDK has been enhanced to provide access to unique data that vSAN can collect. Exposing this data via API helps complementary solutions that use these APIs deliver more value and drive down total cost of ownership. Power CLI has also proven to be a flexible way to interface with vSAN, and vSAN 6.6 introduces new commandlets that incorporate new functionality introduced in vSAN. So what is the difference between data visualization with metrics and data analytics? Data visualization can help make sense of the abstract or information not easily conveyed by numbers. Data analytics excels at taking discrete data points that make no sense on their own into findings that have context and relevance. This is what vRealize Operations and vRealize Log Insight can do for you in your environment. Through their frameworks that hook into vCenter via common APIs, they can offer unique insight to data that is already collected. And they can both take a broader view of the infrastructure over a longer period of time for an environment. Trending analysis is an important part in projecting the needs of tomorrow. Traditionally, using vRealize Operations with VMware vSAN meant that an administrator needed to use two separate interfaces. A new feature known as vRealize Operations within vCenter now provides an easy way for customers to see basic vRealize intelligence from within vCenter. vCenter now includes an embedded plugin that allows for a user to easily configure and integrate a new VROps instance, or to simply select an existing VROps instance. From there, VROps Analytics will be visible in the new HTML5-based Clarity UI, courtesy of dashboards purpose-built for vCenter. The integrated nature of vRealize Operations within vCenter also allows the user to easily launch the full VROps user interface to see the full collection of VROps dashboards. A new way of storing data often invites questions on how data placement and protection are achieved. Let's take a look at this in more detail. vSAN has two methods of protection that historically was the responsibility of a storage array. vSAN, paired with Storage Policy-Based Management (SPBM), allows the user to define these settings on a per VM or per VMDK basis, an unprecedented level of flexibility that was impossible with legacy storage systems. A failure tolerance method defines the approach used for data placement. RAID 1 mirroring, pictured here, or RAID 5 erasure coding. failures to tolerate defines the number of failures that the object can handle while still maintaining data availability, albeit with reduced redundancy. The alternative failure tolerance method of RAID 1 mirroring is RAID 5, RAID 6. This is where data, i.e. components, is striped across multiple hosts with parity information written to provide the tolerance of a failure. Parity is striped across all hosts. When done over the network using software only, this is sometimes referred to as erasure coding. This is done inline. There is no post-processing required. VMware's implementation of erasure coding stripes the data with parity across the minimum number of hosts in order to comply with the policy. RAID 5 will offer a guaranteed 30% savings in capacity overhead compared to RAID 1. Let's take a look at a few examples of how storage policies affect component placement. To keep things simple, each of the VMs in these examples contain a 100 GB virtual disk. The first VM has a storage policy assigned where RAID 1 mirroring is the fault tolerance method and a primary failures to tolerate equals 1. vSAN places a mirror copy of the data on the separate host in the cluster. A small witness component is placed on a third host to serve as a tiebreaker should a split brain scenario occur. The second VM changes the failure tolerance method to RAID 5/6 erasure coding. As a result, 3 data components and parity component are distributed across 4 hosts to enable the virtual disk object to survive the loss of a disk or entire host in the cluster. The next example shows a VM with a policy where RAID 1 mirroring is used and the primary failures to tolerate equals 2. In this case, vSAN places 3 copies of the data on 3 separate hosts and adds 2 witness components as tiebreakers. A primary failures to tolerate setting of 2 protects against the loss of 2 drives or hosts in a cluster. The last example changes the failure tolerance method to RAID 5/6 erasure coding while keeping primary failures to tolerate at 2. 4 data components and 2 parity components are distributed across the 6 hosts in the cluster to achieve compliance with the storage policy. The number of components and their placement is determined primarily by the failure tolerance method and the primary failures to tolerate rules and storage policies. vSAN distributes components across drives and hosts in the cluster based on the storage policy assigned to an object. This helps ensure virtual machine data remains accessible in the event of a drive or host failure. Fault domains are a boundary of failure. vSAN extends the concept of fault domains so that environments can protect against failures such as a rack failure. It gives an administrator the ability to define a logical container that represents a physical topology of a data center. The most common way fault domains are employed are by creating fault domains that represent a rack in a data center, as shown here. The vSAN data would be distributed across multiple fault domains so that in the event of a total rack failure, no system would be compromised. Here we see a 12-node cluster and 2 VMs with 100 GB virtual disks. Both VMs are currently in compliance with their assigned storage policies. The administrator wishes to protect the VMs against the failure of a server rack. vSAN fault domains can be configured to achieve this requirement. As a result, vSAN will comply with the storage policies by distributing components across fault domains, server racks in this case. After configuring vSAN fault domains, we see the first VM is no longer compliant. This is because 2 of the 3 components are located in the first server rack, which is configured as fault domain 1. As a result, vSAN migrates one of the components to another fault domain to comply with the assigned storage policy. This is the same case for the second VM, so vSAN migrates one of these components as well. Now both VMs comply with their assigned storage policies. Data belonging to these VMs will remain accessible if a drive, host, or even an entire server rack goes offline. Using this concept of fault domains, vSAN can protect an environment from downtime in the event of a site failure. vSAN's ability to provide a fully active stretch cluster has already proven its value in data centers. vSAN 6.6 takes this a step further, allowing for storage redundancy within a site and across sites at the same time. This helps deliver effective, affordable protection against entire site outages, as well as host outages within a site. This level of protection is extraordinary, and what many of our customers have asked for. Lower TCO is the result of no need to purchase additional hardware or software while addressing protection requirements with software you already know. Remote offices and branch offices, ROBO, is a common geographic model for many organizations. vSAN makes it easy to run a 2-node vSAN cluster to provide all of the storage needs in these branch offices while using the primary site as the location to house the witness appliances. This makes for a fast, affordable, and flexible management and delivery of services in environments that require this type of topology. Additionally, vSAN Robo Edition licensing has no host limit restriction. There's only a restriction of the number of VMs that may be run in a site. A maximum of 25 VMs can be run on a single site or across sites. Any multiple of 25 requires an additional 25 VM pack license. Additionally, there is no upgrade path from vSAN Robo licenses to regular CPU or desktop vSAN licenses. Many organizations do not have adequate disaster recovery plans and infrastructure. In most cases, this is due to cost. vSAN can be configured as a stretch cluster across metro distances where network latency is less than 5 milliseconds round trip. This architecture provides resiliency against unplanned downtime situations that affect entire sites. vSphere HA is tightly integrated with vSAN and enables fast, automated recovery from a site going offline. vSAN stretch clusters are typically up to 50% less expensive than traditional stretch storage solutions. vSAN also makes a great storage solution for disaster recovery sites. It offers the necessary performance to quickly recover many workloads while minimizing cost and complexity. VMs can be replicated from a primary location to a DR site with vSphere replication. This per VM replication technology can achieve RPOs as low as 5 minutes, and it supports the replication of hundreds of virtual machines. VMware Site Recovery Manager adds disaster recovery orchestration and is integrated with vSphere, vSAN, and vSphere replication. The vSAN witness host is placed at the DR site. vSphere replication is configured between the stretch cluster and the DR site. Combining a vSAN stretch cluster with Site Recovery Manager provides resiliency against local site failure and widespread disaster scenarios. VMware is helping organizations increase their IT agility and enjoy cloud freedom by offering the industry's largest HCI hybrid cloud ecosystem, an ecosystem available today with vSAN and vSphere. For private cloud, vSAN Ready Labs fuels the broadest set of HCI deployment options and partners and is available on over 500 different Ready nodes from 16 different server vendors. vSAN also has generally available integrations with 2 of the 4 largest public cloud providers, AWS and IBM. In addition, over 250 public cloud providers have chosen vSAN to power their offerings at scale, with multiple cloud providers already powering over 10 petabytes of production storage on vSAN. In addition to our VMware Cloud on Amazon Web Services and IBM Cloud offerings, our public cloud provider ecosystem is growing with vendors like Rackspace and CenturyLink, to name a few. Rackspace relies on vSAN to power a wide range of demanding workloads, from traditional business-critical applications and next-generation applications. In addition, CenturyLink has invested heavily in HCI, and today they have over 11 petabytes of production data running on high-performance, all-flash vSAN. Organizations are sending increasing amounts of data from the edge back to the main data center and to public clouds. The traditional model of sending data from the edge back to central locations is getting more expensive and introduces complexity. There is a growing need to process data and make it available for use at the edge. This is referred to as a distributed IT approach. HCI by vSAN can lower the cost and complexity of a distributed IT model. HCI takes advantage of lower hardware costs while delivering the performance and resiliency required for business-critical applications in private data centers, public clouds, and at the edge. Having the necessary computer and storage resources along with valuable data in remote locations such as stores, oil rigs, remote offices, distribution centers, and even the battlefield can lead to a competitive advantage. Even though these resources are distributed, it's still possible to manage them from a central location to minimize operational costs and overhead. Businesses are adopting more cloud-native applications such as Hadoop and Cassandra and want to run them in their private clouds, but running these workloads presents some challenges for traditional infrastructures. vSAN 6.7 delivers optimized policies for big data and cloud-native applications that help reduce the amount of storage capacity used and ensure greater resiliency. vSAN introduces policies that optimize storage for the application VM, allowing the application to manage replication and data availability, which reduces the capacity used by vSAN to protect data that is already protected by the application. This release also supports an even wider set of use cases and applications to drive even greater data center consolidation. We know from recent surveys that more than 50% of vSAN customers are running mission-critical workloads on vSAN, and today we're introducing increasing levels of support for business-critical apps so customers can manage more workloads from a single software stack. As mentioned earlier, with iSCSI support for Windows Server failover clustering, customers will be able to manage more business-critical application workloads by reducing data center complexity and moving towards a unified SDDC experience. VMware is uniquely positioned to provide the most complete solution for modern data centers. From the public cloud to the private data center to the edge, these offerings are available today and help customers gain a competitive advantage through modern IT. vSAN is at the core of these offerings. TCO is reduced by taking advantage of lower-cost server hardware while providing high levels of performance and availability. Features such as storage policy-based management, proactive health checks, cloud analytics, and integration with vRealize Operations Manager reduce operational costs. Customers can take advantage of new flash technology such as 3D XPoint on day one. vSAN also provides the industry's first native HCI security solution for data at rest encryption, without the need for costly self-encrypting drives. vSAN is part of VMware's SDDC ecosystem, which enables customers to experience a unified operating experience on-premises and in the cloud. Simply put, vSAN is the industry's most complete solution for the modern data center. Before you decide which path is right for you, there are some steps you can take to learn more about vSAN and vSAN-powered HCI solutions. First, if you still aren't sure about the fit or right size of vSAN for your environment, your organization can sign up for a free vSAN assessment. This is a tool our team can help you load to get a clear understanding of your environment and some specific recommendations. Next, if you just want to play around with the solution a bit, then we have a free online hands-on lab available 24/7. Lastly, to learn more about vSAN, go to storagehub.vmware.com. You can also check our blog out at blogs.vmware.com/virtualblocks. These are great sources of information for the latest and most up-to-date information about vSAN.